Good afternoon. I feel like starting YouTube videos with, hey, what's up? But I'm 58. That would be really stupid. So just hi. I hope you're having a good afternoon. And let's do a couple more. Specifically, three more. Here's one for Wednesday, the 22nd of April. Um, so I did a whole PowerPoint, number 23, on collecting quantitative data. Now that you have it, what do you do with it in order to answer your research question or start answering your research question? To understand that part of society you want to know more about? Well, you analyze the data, and analyzing quantitative measures of variables, God, the language is so off-putting, helps us understand causes and effects in society. That's in societies. That's generally what quantitative people are doing. They're trying to understand cause and effect. They don't always do a good job of it. They don't always get that far with it. Sometimes they do a great job, but that's what they're trying to do, generally. Not true of qualitative research, which we'll get to on Monday. Now, I started with secondary data, and you may be wondering, like, didn't we cover this? Secondary data collection, or secondary data as a method of collection? Well, yeah, we did. I put it as an addition and an extension to data collection, sort of an overlap, because it shows how collection and analysis overlap. Even if you download a data set from somewhere, you've immediately got to start going through it to make any sense of it, make it at all useful. So just to back up, secondary data analysis means using someone else's data to answer your question. And as I say here, it's really common in the social sciences. Um, they collected it, you didn't. You know that chart of bicycle shops that I keep talking about over and over and over? I collected it. I went out and got the data from a bunch of directories, ancestors to phone books at the Library of Congress, blah, blah, blah. Um, but that's, I would say, more researchers use secondary data than primary data. For instance, when Winfred Avogo teaches Social 300, he uses secondary data. He has students learn how to handle secondary quantitative data. In contrast, when Sue Sprecher teaches Social 300, which she isn't because she's on sabbatical, she has students go out and collect their own primary data, and that's how she does her research. Most, I think, of her published articles, and she has over 100 peer-reviewed published articles. She's amazing. That's why she's a distinguished professor. Um, she collects primary data, but I would guess that this is easier in social psychology or microsociology. It's very common in macrosociology to use secondary data, and here's a long list crammed together. It's single spacing instead of this easier to read space and a half. Um, the General Social Survey mentioned that, the book mentioned that, which the University of Chicago does every year. The Inter-University Consortium for Political and Social Research, they have a bunch of data sets. Um, Governments, every government on the planet collects data. Some governments collect it terribly and some collect it excellently. And I would say most do their best, but there are limitations. You can get secondary data from nonprofit organizations. You can get secondary data from what are called intergovernmental organizations, meaning the members of these organizations are governments, they're not people. So the UN, the United States belongs, Canada belongs, Mexico belongs, etc. World Bank, International Monetary Fund, World Trade Organization. Those are all, right now, the World Health Organization, which is a sub-organization of the United Nations. It collects. Also, it's collecting data right now on COVID-19. The international non-government organizations, these are private nonprofits. that help out, like, well, the OECD and the World Economic Forum are kind of organized to help the global establishment. There's lots of nonprofits like Red Cross, International Red Cross, Doctors Without Borders, Greenpeace. Those also have data. Oxfam, lots and lots of NGOs have data. And one worth mentioning, the book talks about big data, and I don't know that it does a really good job of it, but I'm going to give you an example here. Seth Stevens-Davidowitz, Everybody Lies, and the subtitle. What he did, he's an economist by training, has a PhD in economics, doesn't have a professorship anywhere. He got a ton of Google data. And, can you imagine the IRB nightmare that you would have in trying to get Google data, making sure it's anonymized? But he somehow got tags that showed it was male or female, and he got tags showing where, that each datum was tagged, showing where it was from, which state in the United States it was from. So he downloaded years of Google data and wrote a whole book based on it. It's a fascinating book. But that's secondary data. That's Google's data, and Stevens-Davidowitz used Google's data. That's exactly what secondary data is. So, why? Why would you do it? Why is it so awesome? Because 3 reasons that kind of overlap. The book gives more like 5 or 6 reasons. They really overlap. I'm going to list 3. Operationalization is already done. Sometimes collecting data is not the majority of the time you spend on a project. A good chunk of it is research design and setting up. And so operationalization can be a really messy process if you want to measure deaths. For instance, a good example, how do you operationalize deaths of COVID-19? There's a number of problems. First, there's news reports of people dying in their homes. If you just collect data from hospitals, you're doing a huge undercount. You have not operationalized it accurately. What about deaths in homes? Second, COVID-19 causes deaths in the body, but it also causes deaths because, the whole flattening the curve thing. That means the number of cases of COVID-19 that go to the hospitals overwhelm the hospitals. Well, now people start dying of heart attacks and strokes and car accidents and on and on and on. That would have been treated had the hospitals not been overwhelmed. Do we count those as dying from COVID-19? Do we have a separate category of indirectly caused deaths from COVID-19 and directly caused deaths? Those are questions of operationalization. Those are definitely those questions. And when you get secondary data, somebody's already done all that work, and that actually is a good thing. And I just gave away part of number 2. It saves time and money. Well, it saves time. Somebody's operationalized these variables, but it also saves money. I had to go, as I've said many times, on a research trip. I went on several research trips to around the United States. I went to Minnesota. I went Chicago. I went to Indianapolis, Indiana. I did research in California. Where I was getting my PhD. Went to Hartford, Connecticut, Boston, Washington, D.C., like 3 different times. I tried to go to Philadelphia. That didn't happen. I went to Paris twice. I went to Saint-Étienne, which is a city in southern France. That's expensive and time consuming to gather all this data. You get a data set. You just find a data set online, download it. There it is. Boom, 10, 15 minutes. Get your permissions. That takes another hour, or maybe it takes a few days, and there you are. So this is one reason that it's really, really worth doing secondary data, and most do. And number 3 is a consequence of number 2, that there are so many questions about society. And there's no way to answer them all. If you have to collect your own primary data, I'm just working on bicycles in just 2 countries in just 50 years, a 50-year span. I'm only one person. Uh, if you can, get into international databases, global databases, and nonprofit data collection databases like the OECD, the Organization for Economic Cooperation and Development, their whole purpose is to do research and collect data. The World Bank has a huge data collection arm. If you want to do stuff on globalization, get their data sets, and that is secondary data. You can answer way more questions if you use secondary data than if you use primary. However, nothing is perfect. It's worth knowing the problems, and you don't need to apologize for them. Nothing is perfect. Data are not perfect. You just have to recognize them, you acknowledge them publicly, and you say, hey, this is how I handle them. This is the best I could do. So you may need to rework the data to answer your question. Most secondary data comes in data sets that are in Excel files or other numeric files. You may have to go number by number in, for instance, an Excel file. Change the value somewhat, given that some of the data might be calculated. You aren't caring, in my previous example, number of people who died from COVID-19. Maybe they broke it down by people who died from having the disease in their bodies and people who would have lived if they could have gone into a hospital and gotten treated, because those are casualties. And maybe the third it would be those people who died outside of a hospital at home, and they've gone through coroner records. The coroner, the person who deals with death in every city, counts deaths. And you don't care. You just want to know what the toll is on a whole society. You just aggregate it together. So now you have to change that data. You have to rework that data and add up all the numbers, city by city or block by block or country by country, whatever the data is in. So you may have to change it. You have to evaluate the data quality. Maybe they did a crappy job of counting people who died at home, died accidentally at home. I'm going to go to the hospital. I can't breathe. I'm having trouble breathing. And they don't make it. They die instead. Because people go bad fast. Like they go to bed and don't wake up. They're sick. They have a fever. They have shortness of breath. I'm okay. I can manage this. They don't wake up. That seems to be happening quite a bit. And did the coroner get those as COVID-19 or did the coroner call them something else? That's an issue of data quality. Anything that a government agency collects is politically shaped in some way. It may not be evilly politically shaped, but it is politically shaped. It's a government organization that's collecting, like the coroner is a part of the city government. So there will be pressures and influences and limitations on what any coroner can do. And okay, iterations means repetitions. If you get some great conclusions from your secondary data, you rework it, you evaluate it, okay, you make up for the data quality problems, you calculate, blah, blah, blah. You do all your things, and you want to follow up. You can't. That's it. The data is the data that you have. You can't, if you want to go out and get new data, you've got to do it yourself. Now you're back to primary data. So that's one of the problems of secondary data. You're stuck with the data that you have. It's someone else's data. If you're not going to collect your own, you're stuck. I'm not going to say much about this, but I'm going to say that, at the very least, be generous and say, I got the data from. And sometimes it's, I downloaded it from the World Bank website, which I'm doing for my world history. The chapter on development, I've got a couple of charts that are from the World Bank. And I downloaded the data, and I tell people I got the data from the World Bank. But sometimes you want to put in an acknowledgement that's even stronger because somebody did you a favor and gave you their data set that they collected as primary data, some researcher. collected, and you thank them a little more than just you cite them. You kind of gush, like, geez, thank you so much. And there may be or may not be institutional review board policies for using secondary data. I don't know too much about that, but you have to look. So there's a reading on quantification, and I want to go on this. Seems like a tangent, but it's going to help. It's more of a justification of why to do quantification. And the reading talks about those doing positivist research, which means using a natural science approach on humans, on human societies, human groups. They really strongly tend to quantify. And the reading offers cultural reasons, but I think there's something really straightforward about this, really practical about this. Quantification aids understanding cause and effect. So the logic of causation requires comparison. Let's think this through. It's really obvious. You might go, duh, I already know all this, but it helps to know how this works. So cause and effect thinking implies change, and change requires time passing. I think that's pretty straightforward. If there's no change, or if time hasn't passed, there can't be a change. And so to understand change, we must observe and compare at least 2 times, if not 3 or 4 or 5 or 6 times. Time 1 and time 2, time 3, time 4, time 5, time 10, whatever. I assigned a reading on comparison earlier in the semester, and I'm mentioning it again. To understand change, you have to compare. Again, painfully obvious, but it's better to be explicit. And quantification helps comparison. So you design your measure, you operationalize, you turn a concept into a measure. Number of deaths from COVID-19, if you say that line. Number of deaths from COVID-19. Man, is that vague. That's just a concept. I've broken it down into 3 operationalized measures. People who die from it in their body in a hospital, people who die from it in their body at home, and people who died because the hospital system was overwhelmed. That's 3 different operationalizations. Okay, then we measure those 3. We go out and get statistics from New York City, from Chicago, from Bloomington Normal, from Decatur and Peoria. Very few people have died in Bloomington Normal, but they have from COVID-19. I'm not even sure if the Advocate or OSF here are overwhelmed or not yet. They may not be, but they certainly are in Chicago, and they absolutely are in New York. Those exact numbers, precise numbers, really help the comparison. It's very normal to just say more or less and leave it at that, and to not really make it explicit that more or less implies quantities. And it's better to say 10 versus 20 rather than more or less, 10's less than 20. No, 23, that's even more precise. If we get exact precise quantities, we know much more about cause and effect. So all the problems mentioned in the reading. So quantification leads to oversimplification. Quantification leads to alienating groups from their own experience, which is true. You're turning their lives into a bunch of dead numbers. It helps bureaucrats and maybe professors escape accountability. Well, it's in the data, it's the numbers. Numbers don't lie. Yeah, they do. And making some phenomena invisible. All of these are criticisms by qualitative researchers. All of them are valid. All of them are accurate. That's why I'm a believer in multiple methods. I think qualitative researchers are just as limited in other ways. So know the criticisms, accept the limitations, and then allow quantification to tell you some things. So one method of analysis is descriptive statistics. Once we've measured, we do something with the data. A good first step is to figure out the typical and the atypical, the variation from the typical in the data. This helps us better understand whatever variable or variables we've chosen. The concept turned into a measure, that's a variable. And you have a measure of a concept. That's one person dead from COVID-19. You have another measure, another person dead. Okay, now the count is 2. Now another person, 3, another person, 4. Blah, blah, blah. It goes on. Repeated measurement. Eventually, you've exhausted all the people who died of COVID-19. I'm sorry, I know at least one person in this class has lost somebody from it, and probably others, but this makes research real, because if there were a way to stop it, you would have stopped it, right? You didn't want that relative gone. So again, research helps us learn, helps us change society. So you're measuring these deaths. You have a big pile of data. Then you have what are called statistics, and people misuse the phrase or the word statistics all the time. I did until I got into sociology. A statistic is a numerical summary of raw data from a sample. And the whole point of analyzing the data to get these various summaries is to reveal patterns. And the patterns, the summaries to reveal the patterns, I think C is in my PowerPoint is wrong, but it's like almost 1 o'clock in the morning. I got to get this to you. I screwed up on Monday. You're going to get this on time. So I'm just going to keep speaking. Patterns: mean, central tendency pattern. Median, another central tendency. Mode, another central tendency. Standard deviation. Pattern away from the center. Things like that. Typical, which is what measures of central tendencies are trying to get at, and variation. That's what standard deviation gets at. How do you get away from the center? The other, and I would say much more common use of statistics is inferential statistics, but you need to understand the variable. So number of deaths per COVID-19, a number of cases of COVID-19. That's a real issue right now in the news, and I've seen Iceland and that study from Santa Clara and another study from Los Angeles. Neither of those two California studies are peer-reviewed yet, but all that testing is showing that the numbers in the population are much higher than people think, and so we want to be able to draw inferences to get the damn death rate down. So inferential statistics go beyond descriptive statistics, and it's a reminder to tell you that an inference is drawing a conclusion about the unobserved from what you have observed. When you infer, you draw a conclusion about something you haven't seen. So really, I've used this example before we all scattered and got stuck in our homes. Dogs. I think I did. Give a dog a treat. Dog eats it right up. Hey, he likes it. Give a dog a piece of, well, for instance, we had a dog named Capital who was an awesome dog, and he wouldn't eat lettuce, but he loved carrots. How do I know he loved carrots? Because you hand him a carrot, he'll just chomp on it, and Lisa loved watching him chomp on carrots. But every time we handed him lettuce, put it in his mouth, he just dropped it on the floor. Technically, you are inferring. Capital never told us, I hate lettuce. Why do you keep giving me lettuce? I love carrots. Give me more carrots. He never said that. He's a dog. Same with babies. Babies crying. Oh my God, please baby, shut up. Put a nipple in the baby's mouth, a human nipple or a bottle nipple. I just so you know, I use bottle nipples. Um, Milk is at the end of it. Baby starts drinking. Baby shuts up. Baby looks so much happier. We infer baby was hungry. Babies can't tell us either. After a year or two, yes, they can. And we are no longer inferring. We know. Um, in research, inferences are just much more consciously done. We don't just say, oh, hey, the dog likes it, the baby was hungry. We consciously know that what we are doing is inferring. And so inferential statistics are drawing unmeasured conclusions about a population from the measured in the sample. So the whole point of sampling properly is to learn about the target population. And we want a representative sample so we can come up with a valid inference. We actually have figured out what's happening in the real world correctly. We're not wrong. That's validity. Strictly speaking, as long as we have a sample and we haven't taken a census, we are making inferences. If we do a census, we know. If we draw a sample, we don't know, but we're pretty sure, especially if we've done a good job. So there are two types of inferential statistics. One is parameter estimation. So this is a problem because people misuse the word parameter all the time. And parameters, it sounds like people with, well, nobody uses pocket protectors and calculators anymore. Everybody is carrying around a video camera and a calculator and a flashlight and a phone and a camera and, you know. So nerd stereotypes from the 80s don't work anymore. But people who nobody wants to talk to because they're boring use the word parameter in high school. But actually, a parameter is a measure of the characteristic or the variable in the population. And statistic is that same thing in the sample. And we do inferential statistics because we almost always have a sample. So that's the way to use those terms properly. The second type of inferential statistics is hypothesis testing. This is most of what published research is about. And estimating parameters is a good basis for it. Descriptive statistics is a good basis for it. But ultimately, what are you trying to do? You're trying to understand causation. And a hypothesis is a statement about how an independent variable influences a dependent variable. Technically, you're not saying X causes more COVID-19 deaths or fewer COVID-19 deaths. You're just describing a relationship between an independent and a dependent variable. Do they vary together? Do they correlate? When one goes up, does the other go up? Or do they vary against each other? Very inversely, when one goes up, the other goes down. And that holds true. The more it goes up, the more the other one goes down. But really the thinking behind a hypothesis is you're basically saying, look, this causes this effect. And it's a proposal. You're proposing this causes this effect. And that's why earlier in the semester I said theories are made up of a series of propositions. And you turn the proposition, the explanation you propose, into a hypothesis through operationalization. Have I thrown enough shitty social science language at you yet? I don't think I have. I'm throwing more at you. So hypothesis testing, therefore, means you use the statistics that you've collected from your sample, to understand the relationship between the independent and the dependent variables. So, an example would be the one that I keep using. An early hypothesis was Chinese men smoke like chimneys and Chinese women don't. And Chinese men die at twice the rate that Chinese women do of COVID-19. That was a hypothesis. And just from reading the news websites, it got shot down. Men still die of it here, and we don't have that. Smoking rates are not very, excuse me, particularly different between men and women. They are, but not nearly as much as they were in China. So if we were to test that before it spread from China, we would get statistics, maybe census data, meaning total sales of cigarettes in China. That would be more of a census. But really, if we're going to figure out who's buying them, that you're going to end up with a sample. Is it men buying them? I mean, suppose women buy most of them, and then go home and hand them off to their husbands. Maybe that's the way Chinese society works. Here's your damn cigarettes. Go smoke out. I don't know. So we're going to rely on samples to understand the prevalence of smoking between the sexes in China. And then we're going to have to rely on, we hope, all cases of deaths from COVID-19 in China. But again, I mean, just a few days ago, the Chinese government, I believe it was the government, released figures saying, no, actually, the numbers are 50% worse than we thought. So whatever number we gave you, that's 100%. Actually, the numbers are like 150%. But if you were to take that hypothesis and test it, that's what you're doing. You're trying to get, various central tendencies and understand those variables, and then you relate them in a hypothesis. So how do you actually test? And this is really messed up. It's backwards thinking. It messes with your head. But it's the best we got. So what do? You've got a proposition that you are operationalizing into variables. And what you're actually doing is, what are you going to actually do when you get out the numbers and crunch them with SPSS? You're going to test the null hypothesis. The null hypothesis is that your hypothesis is wrong. There's no effect. And again, you can't test a hypothesis if you can't falsify it. And the null hypothesis is the falsification of your hypothesis. It's a statement that your idea is false. I think there's a relationship between smoking and death from COVID-19. And the null hypothesis is, no, there's not. There's no relationship whatsoever. So the alternative hypothesis is your hypothesis. It's if we're going to be generous to the people who thought this up, including Karl Popper, Sir Karl Popper, the philosopher of science, who I keep mentioning, they're being modest. Let's go with, you're wrong. Let's go with, there's no relationship, and let's see if that's right or wrong. So the alternative hypothesis, H sub A, is, yeah, there's a relationship. So what you do is you always test the null hypothesis. When you're actually running the numbers, you test the null hypothesis, not yours. Now, rejecting the null hypothesis means the idea that there's no relationship is false. We've falsified the falsification, which is not necessarily true. I mean, if you think about it. Okay, I've falsified the falsification. That's messed up and confusing. Does that mean it's true? No, that's the problem. If we reject the null hypothesis, if we say, well, we thought there was no relationship, we have to throw that out. We then retain, the language is always retain the proposed hypothesis. What you're doing is keeping it around for a while. Okay, smoking does, I know this one I'm using, we threw out months ago. But yeah, smoking does have an effect. The alternative hypothesis is better than the false one, which we had to throw out. The null hypothesis, we threw it out. It's the best we got for now, so we failed to show it's wrong. We don't say we proved it. We just say we failed to reject the alternative hypothesis. We rejected the null hypothesis, therefore we failed to reject. See what I mean? This messes with your head. But this is how it's done. So again, in a sense, it's modesty. We're not saying, hey, I've proved it. We're saying, looks good for now. We're going to keep throwing stuff at it, but for the moment, it looks okay. Oh, finally, the last slide. So I wanted to say one more thing because I realized it was like the 6th time I've taught this class, and last semester, the 5th time I realized this. And I'm putting this stuff in to help you with 275, which you might be taking right now. The real world is messy, and it's lovely to do experiments, but there's a reason that we like natural experiments, because they're part of the real world. They make more sense. And statistics, all these numbers we gather, are in a way the non-experimental measurements of experimental and control groups. So all the possible statistics we could collect are deaths, testing samples, governors and mayors' orders, what different countries did. So there's lots and lots of testing. Germany and South Korea have done that. And then they do contact tracing. And then they do isolation. So if you test like crazy, and the people in Iceland have tested like crazy, anybody can just walk in and take a test. Not here. But the Icelanders, they test. The South Koreans, they test and contact trace and isolate. The Germans test and contact trace and isolate. And then hospitalize people earlier than, people do anywhere else. They said, if you're in a hospital already and you get worse, we can treat you better. And their death rate is lower. In other words, in a lab with an experiment, you vary one thing. And if it changes the effect, that one thing is the cause. Real life is messy. You've got 5 or 6 different possibilities. Contact tracing, testing, contact tracing, isolation, early hospitalization, masks. That's another one. Those are 5 different independent variables. Which one is really good, or how strong is one versus another? So when you talk about statistically controlling for things, you're applying the logic of experimentation. You are creating, you're estimating, multiple counterfactuals. So if we try to test for hypothesis test, just testing, what's the influence of testing? We'll control for mask wearing. We'll control for governor's shutdown orders. We'll control for contact tracing and isolation. And we just want to look at testing for COVID-19. That would mean that we're controlling for all those others. We're holding them constant. We're not letting them influence. And you can do that with statistical measures, and Webb Leonard would be happy to tell you how. But the basic logic is you're controlling for all of them because you need a control group. You need control and you need the experimental groups. It's the logic of experimental thinking. So I don't know that I've explained that really well, and if you have problems with that, with understanding that, hit me up in the comments, in the forums, or in the forum for number 24. But do keep in mind that when you talk about statistically controlling, you are, in a way, estimating counterfactuals, and you are therefore using the logic of experimentation, and behind that is the logic of how causes work. So, I hope I've done a decent job of helping you understand this argument that analyzing quantitative measures of stuff out there in the world, which we're going to call variables, helps us understand what causes what and what the effects are in human societies. And I hope relentless focus on COVID-19 and the death rate has not been too emotionally damaging or depressing, but it shows the stakes of social research. So I will talk to you in the forums or next Monday.